We're going to start diving into more advanced features such as lifecycle functions, the virtual DOM, and components. We're going to begin by talking about mounting the Vue instance. This topic is something we discussed briefly already, but I want to review the topic again. It's going to have relevance in the upcoming lecture. In the resource section of this lecture, I provide a zip file with everything you'll need. Download it, unzip the contents, and point your editor to those files. Pause the video if you need to. The files in this example don't contain a lot of code. It's a simple application. We have the div tag with the ID of app. Inside the element, we're rendering an expression. If we switch over to the script file, we'll find a new app being created. Inside the instance, we have the message data property set to a string value. Lastly, the CSS file contains some basic styles to help make things visually clearer. Just by looking at this code, you probably already know what to expect. The expression will be interpolated into the string hello world. I'll switch over to my browser, and sure enough, the message does get displayed. Everything works without a problem. The process of Vue inserting itself into the document is called mounting. The moment we see the expression interpolated into the document indicates that Vue has been mounted. Let's say we didn't want to mount the Vue instance right away. In some situations, we may want to mount the instance at a later time. We would want to mount the Vue instance later because we may want to load other modules before rendering the application to the user. In some cases, the element we want to render the application in may not be available initially. We'll want to defer Vue from starting the application. Back inside the editor, open the JavaScript file. We're telling Vue to mount itself to the div tag with the ID of app. We're going to remove the mount function we chained. Vue will still work. It'll continue to initialize itself with the data and methods. However, it will not get mounted to any element on the page. Therefore, we can't interact with the instance on the document. We can still interact with it via JavaScript, but the average user will not be able to unless they know JavaScript. By not mounting the application, it will not appear in the document. You may want to do this if you don't want the user to interact with the application right away, but will at a later time. Let's pretend the element we needed didn't appear until 3 seconds later. We're going to set up a set timeout function with a delay of 3000 milliseconds. Inside the callback function, we're going to call the mount method to insert the application into the document. The mount method doesn't always have to be chained after creating an app. We can call it at any point in time after the app was created. Alright, let's give things a test. Go ahead and refresh the page in the browser. Immediately, we'll see the expression on the document. It hasn't been interpolated yet. After 3 seconds, the set timeout function is triggered. The Vue instance gets mounted to the div tag with the ID of app. The mount method gives us the flexibility of presenting the application whenever we need to. Most of the time, you'll want to mount the application immediately, but it's always good to know you have an alternative if you ever need it. Back in the JavaScript file, I'm going to comment out the timeout code. We won't need to mount the application at a later time. We'll call the mount function after creating the instance. This isn't any different than chaining the function. However, I like to do this because it looks cleaner, in my opinion. Constantly chaining functions can be a bit confusing. Call the mount method however you prefer. That wraps it up for this lecture. We'll continue in the next one. Vue goes through a process called the lifecycle. The lifecycle enables us to run code when a new instance is created. We're not limited to creating the data inside our instance. We can run code during the creation process and even after the instance is destroyed. Allow me to elaborate further. Before the Vue lifecycle may begin, the instance has to be created. That's done using the vue.createApp function. This function is where you pass in your settings and data for Vue to work with. During this process, Vue will begin the lifecycle. Vue will create areas within itself where we can inject code and do whatever we want. The very first thing Vue does is add reactivity to your data. This process is where it begins to watch your data for any changes. Before that happens, you have the opportunity to run some code. The first lifecycle hook that occurs is the beforeCreate hook. At this point, the Vue instance hasn't been fully created. This means you won't have access to your data or any of its methods. Once everything has been initialized, the Vue instance is ready. We are provided another lifecycle hook, which is the created hook. Unlike before, we can access the data and methods inside the Vue instance. However, Vue is not mounted to any template, nor will anything be rendered onto the page. After the Vue instance is created, it'll start looking for a template. This part of the lifecycle starts the moment we call the mount method on the application. Vue will scan the template code and begin processing it. This process is what's called compiling. We haven't talked about compiling in depth in this course, but I promise we will soon. All you have to know is that this is where Vue will scan for directives, expressions, events, and bindings inside the template. Once the template is compiled, Vue will replace the content inside the element we selected with the mount method with the compiled template. Before that happens, you have the opportunity to hook into the beforeMount lifecycle hook. Once mounting is completed, you can hook into the mounted lifecycle hook. At this point, Vue has inserted itself into the document. We'll be able to see the rendered template on the document. All expressions, directives, and bindings have been processed. After the mounting phase is completed, your application will watch the data for any changes. This usually happens during events such as mouse clicks or inputs. Anytime the data has been updated, Vue will then update the template, and the cycle just repeats. We are provided two hooks during this process. The first hook is the beforeUpdate hook. This gets triggered after the data has been updated, but has not been applied to the template. The next hook is the updated hook. This hook runs once the template is patched with the updated data. These two hooks I'm introducing are mainly used for debugging. I wouldn't recommend you use them for applying changes to the data. Computed properties and watchers will cover 99% of the scenarios you come across. This is the life cycle we've been dealing with throughout this course. Soon enough, you will become familiar with the lifecycle process. We're going to dive into the code in a moment, but there is another part of the lifecycle process we haven't been able to experience yet. We have the ability to destroy the Vue instance. This means that any reactivity, events, directives, or bindings will be disabled and gone. You may want to do this in case you want the user to no longer interact with the application. The way you destroy the instance is by calling the onMount method. Once the method has been invoked, Vue will take care of the rest and finally destroy the instance. If you call the method, there's no turning back. During this process, there are two hooks we can use. The first hook is the beforeUnMount hook. This hook is called before the instance is destroyed. Your application is still fully functional and present on the page. You're free to access any of the data and methods in your Vue app. The last hook is the unmounted hook, which is triggered once the Vue instance is destroyed. You won't be able to access the instance anymore. Any data or methods will be gone and inaccessible. That's it. That's the Vue lifecycle. Now that we have an overview of things, let's learn how to use the lifecycle hooks in the next lecture. In this lecture, we're going to look at how to use the lifecycle hooks in our application. We'll be working with the code we had in the previous lecture. The very first hook is the beforeCreate hook. We can use this hook by adding it to the configuration object we passed into the createApp function. This goes for the other hooks too. It will be on the same level as the data property. The value must be a function. This hook is called before the Vue instance is initialized. At this moment, we won't have access to the data because Vue hasn't created the proxy methods. The instance will not be reactive. We're going to console.log a message to prove that this method gets called, beforeCreate function called. Along with it, we're going to log the message property we have inside the data object. We'll see the results of this soon enough, but let's keep moving forward. The next life cycle is the created hook. This hook will be set to a function. All life cycles are functions. I'm going to copy the log message we used in the before create lifecycle. We'll make a modification to the message to help indicate which lifecycle this message is being logged from. Everything else will leave the same. We'll be performing the same test as before. The next lifecycle we'll take a look at is the before mount lifecycle. This hook gets triggered once the template has been compiled, but hasn't been added onto the page yet. We'll paste in the same message as before, but change the name to before mount and set the second log to this.$el. I'm introducing a new property called $el. Its value will be the element Vue is mounted to. It's available once Vue has been mounted. You'll be able to see the value once we run the code. Up next, we have the mounted lifecycle. This hook gets called after the template is mounted onto the page. At this point, we have a fully functioning application. We're going to log the same message we had for the before mount hook, but change the hook's name to mounted. Alright, let's test our code. Go ahead and refresh the page. The application will work like normal. Let's view the console to see what appears. We will have a total of 4 messages. The first message is from the before create lifecycle. This hook gets called before the Vue instance proxies our data and methods. It's the first in the series of lifecycle hooks. Taking a closer look, we'll see that the message property we tried logging is set to undefined. This is because the data property hasn't been proxied yet. Therefore, the this object won't be able to print to our data properly. This limited scope goes for our methods too. The next method is from the created lifecycle. The data and methods in the instance have been proxied. This is proven by the fact that we're able to log the message data property successfully. Then we have the message from the before mount lifecycle. For the second message, we logged the $element property. This property will be set to null because the application doesn't have access to the template yet. Lastly, we have a message from the mounted lifecycle. Unlike previously, the $element property will hold the template after it's been compiled. The expression is no longer present. It's been interpolated to the message data property. These are the first 4 lifecycle hooks. It's pretty clear what each one does. The most important thing to understand is what you have access to inside each of them. Some lifecycle functions will provide you with very little, while others give you access to everything. One of the main questions I get asked by students is the difference between the created and mounted lifecycles. The mounted lifecycle is only triggered once the template is compiled and inserted into the document. We'll have access to the template if we need to make changes to it. If you need the template rendered on the document, you need to use the mounted lifecycle. If you only need the data, then you can use the created lifecycle. Alright, let's move on to the rest of the lifecycles. The next set of lifecycles are for when updates occur. Let's go back to the editor. The first one is the before update lifecycle. This hook gets called whenever an update in our data occurs, but before these changes are applied to the template. I'll log the following message: before update function called. We will not be logging a second message. Unfortunately, we don't have access to which property was updated. This hook will get triggered upon any changes to the data. Like I said before, this is usually used for debugging, but you can also update additional data if you need to. The last life cycle is called updated. I'll log the message updated function called. Alright, let's give things a test. I'll refresh the page. We will see everything work as before. The updated lifecycle hooks are called on changes. We don't have a way to change the data inside the document, but we do have the Vue developer tools. Inside the Vue Developer Tools, we can access the data inside the application. The developer tools allow us to change the data without having to create a UI. This tool can be helpful for quickly debugging an application. We'll change the message property to something else really quick. The changes will be reflected in the document since we're using an expression that outputs the message data properly. If I were to switch back to the console, you would see the new lifecycle messages appear. They are thus giving us a clear indication that the correct functions were called. The lifecycle functions we're using will be called whenever an update occurs. The last set of lifecycle functions we'll look at are for when the instance is destroyed. Let's take a look at those now. Switch back to the editor. Inside the Vue instance, we'll add the before unmount lifecycle. This hook gets triggered before the instance is unmounted. This hook will allow us to perform last-minute changes. We still have access to the data and methods in the Vue instance. The app is fully functional. We'll log the message before unmount function called. The next lifecycle is called unmounted. This hook gets triggered after the instance is unmounted. Any directives or events you previously had are gone. We'll log the message. Alright, let's give things a test. Refresh the page. No errors will appear so far. Now the question is, how do we unmount the instance? Vue provides us with a method called unmount. Inside the console, we'll use the VM object and call this method. The method requires we pass in the element where our application is mounted to. This is because Vue needs to know where to remove the template it renders. This method will unmount the instance from the document. After calling this method, we will see both messages appear. The template has been removed from the document. We won't even see the uncompiled version of the template. The page is completely empty. We will not be able to interact with the application anymore. The data, events, bindings, and directives are all gone. That's the lifecycle hooks in a nutshell. They're pretty powerful and allow us to access different parts of Vue. You most likely won't use all the lifecycle hooks, but they are there when you need them. In the resource section of this lecture, I provide a link to the lifecycle documentation page. It has a diagram like the one I showed you before. It has more info though. The chart I showed you is a more simplified version of the Vue lifecycle. I showed you a stripped down version because there are more topics we haven't gone over yet. This diagram would have been more confusing to explain than what I had. Surely enough, we will go over some of the missing pieces. For now, you will be good with what I've shown you. By the end of this course, you will be able to understand this diagram Vue has provided fully. In this lecture, we're going to talk about the virtual DOM. Learning about the virtual DOM is mostly theory. It's something that's handled for you by Vue. You don't have to worry about it much, but you will hear about it the longer you use Vue. So it's good to know what it is and why Vue implements a virtual DOM. First, we need to understand what the word compile means. To put it simply, to compile something means to take something in and turn it into something else. In the programming world, it usually means to take in your code and convert it into other code so that another program can understand it. One example is the JavaScript language. Machines don't understand the JavaScript language. You need to run it through a compiler that will convert it into machine code. The browser handles that process for you whenever you load a JavaScript file. Vue does something similar. That begs the question, what is Vue compiling? Why does it need to compile anything in the first place? To answer the first question, Vue is compiling our templates. When we use the mount method, Vue will scan the contents of the original template. This includes the expressions, directives, bindings, and anything else inside of the template. It will take it in as a string and convert it into an object. Here is a basic example. On the left, we have an h1 tag with some content inside of it. On the right is what it gets compiled to. It gets compiled into an object. The object will contain the tag name, attributes, and content inside the element. Let's take it a step further. A step up from this would be nested elements. In this example, the template has an additional span tag surrounding the text. Everything is the same on the right except for the content property. Instead of a string, Vue will store the content as an array of objects. Each object represents a child element in the parent element. In this instance, we have one object which contains the same properties as before. To summarize, Vue is compiling our template. It converts it from a string of HTML to a JavaScript object. That leads us to the next question. Why does Vue compile our templates? The two main reasons are that it's easier to manage, and it provides a performance boost, especially for larger applications. Let me explain more. Firstly, you should be familiar with the concept of a DOM. DOM stands for Document Object Model. If you run JavaScript in the browser, you will be provided with an object called the document. Through this object, you can retrieve elements on the page or make changes. In this example, I'm selecting an element by its ID. Then, I'm changing the inner HTML of that element. This process is the fastest way to update the document. Actually, it's the only way you can update the document. Make no mistake, the DOM is pretty darn quick. The problem with this approach is it can significantly slow down your application the more elements you have. Imagine a scenario where we are listing users. We're rendering the list of names onto the page using paragraph tags. Simple enough, right? Well, what if you remove a name from the data? In that case, you would have to scan each individual element. If an element is using the data, you should delete it from the document. You would also have to check for their attributes and children as well. Performing an operation like this would be rather expensive. You would have to continually check each element using the DOM functions like getElementById or querySelector. These functions return properties and methods you wouldn't need to check. That creates a lot more overhead the more elements you have. Going through the DOM and comparing values is costly. That's only the first part of the operation. After you've performed comparisons, you need to update the DOM. This includes adding or removing elements. An alternative to this would be to just render the entire template without having to check each element. But that's also inefficient. Repainting a page is costly, especially if you have an application that's working with data constantly. Rather than replacing the whole template, it's smarter to update the elements and attributes that need to be changed. Alright, so how is the virtual DOM any more efficient? The virtual DOM is a lightweight copy of the actual DOM. It doesn't have as many properties or methods as the original DOM, but that's okay. Its purpose is not to replace the DOM. By having a lightweight copy, the process of checking each element is much faster. Once it's finished, it'll perform what's called a patch. Patching is the term used to refer to the process of updating, adding, or removing elements from the page. This includes the attributes or content of an element. Vue will only update what's necessary. It won't update the whole template. If the text inside an element changes, then that's what will be changed. The entire element won't be overwritten. It does this process in bulk. If multiple changes need to happen, Vue will apply it all at once. This way, changes are smoother. Overall, the virtual DOM is an extra step in the process, but it's more efficient and faster. It scales incredibly well. You can have thousands of elements on the page. Vue will be able to handle the document without a problem. I'm presenting a simple example. Can you imagine an application with hundreds of elements and attributes? The traditional way of doing things would result in a slow app. The virtual DOM is optimized to handle large data efficiently. One of the most exciting things about the virtual DOM is that it's unnecessary to add classes or IDs to an element. I'm not sure if you noticed, but we didn't have to worry about adding classes to our elements to select them. Vue knows precisely where to update the template without using classes or IDs. That kept our code reasonably minimal. Of course, you would still use classes for adding styles to an element. It's just that it's not required to add classes or IDs for selecting an element. This also keeps things minimal in the JavaScript file. We didn't have to query for any elements. Instead, we updated the data. From there, Vue took care of updating the DOM for you. I've talked quite a bit about the virtual DOM. Let's recap everything. The virtual DOM is a JavaScript object. It is a lightweight copy of the actual DOM. Whenever a change occurs in your data, the virtual DOM will also get updated. After the virtual DOM is updated with your data, it'll sync itself with the actual DOM. It won't add or remove anything if it doesn't have to. It'll patch certain areas wherever the data is used. As long as you understand that, then you will be good to go. In the next lecture, we'll get back into some coding. In this lecture, we're going to get a basic understanding of how Vue implements reactivity with our data. This information can be useful if you're ever in an interview. You'll be able to explain Vue's reactivity better compared to other candidates. From what we understand so far, reactivity is when a program is able to react to changes. One famous example is Excel. Excel is a spreadsheet program. One of the more useful features of Excel is it's able to calculate results on the fly. I have Excel opened on my machine to give an example. I'm going to write two numbers in a single column. If I want to get the sum of both numbers, I can highlight the two cells. Then, I'll right-click to bring up the menu. I'll select Quick Analysis. This option will bring up a list of calculations we can perform on the two values. Under the Totals option, I'll select Sum. The sum will be outputted below the other two cells. I can freely update any of the two cells. The third cell will be reflected with the changes. Excel is able to react to changes on the fly. Vue replicates this behavior with our app. Whenever our data changes, the document will be updated to reflect the changes. Under the hood, Vue is using something called proxies. I've mentioned proxies a few times already, but how exactly do proxies work? Let's dive into proxies. In the resource section of this lecture, I provide a link to CodePen. CodePen is a playground for quickly prototyping projects in the browser. We're going to be using it quickly to look at how proxies work. We don't need to set up a new project for this demonstration. Let's create a new pen. We don't need CSS for this example. It's safe to minimize this section. We're also going to open the console to help us with debugging. In the JavaScript section, we're going to create an object called data. You can imagine this object the same as the object we would return from the data function. We'll add one property to this object called name. The object we created is very plain. We can directly access its properties and update them too. In a complex app, we'll most likely want to observe this object. When I say observe, I mean watch for changes or how it's accessed. By becoming aware of how the object is treated in our app, we can perform additional actions. At the moment, we can't observe the object. We don't know when it's accessed or if the values have been changed. One way to force our app to observe the object is by using proxies. Below this object, let's create a new variable called observed data. Its value will be a new instance of the proxy object. The proxy object was introduced to address the exact problem we're facing. It allows us to observe an object. A proxy can be created by creating a new instance out of this object. It has two arguments. The first argument is the object that should be observed. We'll pass in the data object. The second argument is another object. We'll pass in an empty object. We'll talk about this object in a moment. The new instance that's returned is a copy of the object we passed into the first argument. We can treat the observed data object as if it were the data object. For example, let's log the observed data.name property. In the console, the name property was logged. The observed data object is the same object we had previously. The main difference is that we can add additional functions to it that will be called based on how the object is being interacted with. We can define functions in the object we passed into the second argument. The first function we'll look at is called set. The set function will be called whenever any of the object's properties are about to be updated. This function is called before the update occurs. There are three arguments we can accept in the function called target, key, and value. The target argument references the object we're accessing. You can think of it as the equivalent to the this keyword. The key argument is the name of the property that's being accessed. The value argument represents the value that the property will be set to. By defining this function, the property will never be updated. The reason it won't get updated is because the set function will be responsible for updating the property. If it didn't exist, the default behavior would occur. In our set function, we can have the default behavior back by setting target to the value. As you can imagine, this gives us a lot of power. The set function will always be called for any of the properties on the object when they're updated. We can use this opportunity to perform additional actions. For example, let's try updating the document with the new value. In the HTML section, we'll add a div tag with the ID of name. Next, back in the set function, we'll select the div element with the document.querySelector function. We'll update the inner text property to the value argument on the element selection. Lastly, let's update the name property. The set function won't be called until we update one of the properties on the object. We only have one property, which is the name. We'll update the name property on the observed data object to a different value. On the preview, we'll be able to see that the name gets outputted after changing the property. The great thing about this proxy is that the document will always reflect the latest value no matter how many times we update the name. It'll always output the most recent change. By using proxies, we can create our own reactive JavaScript framework. Luckily, we don't have to. Vue comes with reactivity out of the box. It even introduces edge cases that we haven't even accounted for in our example. We don't need to recreate the wheel. Behind the scenes, Vue is using the proxy object to help it keep track of changes to our data. In the resource section of this lecture, I provide a link to the proxy object documentation page. We aren't limited to watching for changes. We can watch for when the object has been accessed or if any of its properties have been deleted. Feel free to read up on this object. This information can be handy if you're ever in an interview and want to stand out from the other candidates. Understanding how reactivity works can really set you apart. There are two ways to create a template. Up until now, we've been creating the template inside the HTML document. We have the option of creating the template inside the Vue instance. Let's try creating the template inside the instance instead of in the document. Starting with the document, let's cut the code inside the div tag with the ID of app. We'll leave the parent element alone. It's still required to have an element on the document for Vue to start the mounting phase. Then, switching to the JavaScript file inside the configuration object, we're going to remove every lifecycle function. We're going to get rid of any commented code since we no longer need it. Templates can be directly loaded in the Vue instance by adding the template property. The value for this property must be the template Vue will compile. I'll paste in the code we cut earlier as a string literal. I'm adding this in as a string literal to take advantage of multi-line code in ES6. You can use regular quotes if you wish. Let's view this in the browser for the outcome. Refresh the page on your browser. The template is compiled and rendered onto the page. The expression interpolates into the value we had in the data. So what's the difference? Well, there's not much of a difference. They both accomplish the same thing. You may want to use the template property if the HTML is stored inside a different file. You would need to make a request to grab that file. Then you would use the response from the request as the value for the template property. That's just one scenario. Usually, I don't recommend using the template property for two main reasons. The first reason is that most editors won't be able to pick up on the HTML syntax inside a JavaScript file. Even my editor will highlight everything as a string. The second reason is that you can't do multi-line templates easily. I'm using a string literal, but string literals are not compatible with older browsers. Therefore, you'll have to use quotes and append each string together for each line. That makes things harder to manage. I always recommend storing the template inside the document and let Vue take it from there. There is another option, which is usually the preferred option for more complex applications. There are multiple versions of Vue available for download. However, all of them can be broken down into two categories. There are the versions with the compiler and the versions without the compiler. Notice how the only difference between these two types is the compiler itself. The compiler, as we learned previously, is responsible for taking in your template as a string. It'll convert the template into an object for the virtual DOM. Whenever you use the template property or the mount method, the compiler will be used. Throughout this course, we've been using the version with the compiler. Vue grabbed the contents of the element we passed into the mount method and compiled it. However, we do have the choice of using Vue without the compiler. The main advantage of using Vue without the compiler is the size reduction of the file. By removing it, Vue will be reduced to about 30% of its original size. This reduction will, in turn, increase loading times. Vue is also much faster since it doesn't have to worry about compiling your templates. The downside of using Vue without the compiler is that it's harder to read and manage without the proper tools. Fortunately, the development team behind Vue has made using Vue without the compiler simple. They have an official toolset we can leverage. This toolset gives us the performance boost of using Vue without the compiler. We'll be diving into how to use the proper tools soon enough. First, I want to take the time to explore with you the compilation process. The difference between the two versions is the compiler. Even if you use the version without the compiler, you still have access to features like directives, expressions, bindings, and events. Every feature is available to you except the part where Vue will process your template and convert it into an object. In the resource section of this lecture, I provide a link that describes the different versions of Vue. It's referred to as builds in the documentation. There are a number of builds here, but as I said before, it's narrowed down to two different categories, the one with the compiler and the one without the compiler. The build with the compiler is referred to as the full build. The build without the compiler is referred to as the runtime only build. For most of this course, we've been using the Vue.js build. It's the full version, meaning we've been using Vue with the compiler. Below are definitions for the words used in the documentation. For the word compiler, Vue defines it as the following: code that is responsible for compiling template strings into JavaScript render functions. What exactly are render functions? Let's look into that. In my browser, I'm going to open the Vue application we've been working with in this section. To save some time, we're going to run the examples in the console panel instead of writing the code in a file. Let's create a variable called res. The value of this will be the Vue.compile function. The Vue.compile function is the exact function Vue uses internally to process your template. You're required to pass in the template as a string. By default, Vue will pass in the template you select in the mount method. However, since we're calling it manually, we'll need to do that ourselves. We'll pass in some paragraph tags with some random text. For fun, I'll throw in a v-if directive with the expression set to true. We're storing the value since the compiler only compiles the template. It does not store it anywhere for us. Running this line will not do much. However, the res variable will be available, and we can call it next. The value assigned will be an object. The object will have a property called render. I'm going to log this property next. This function will return what's called a render function. It's a function that will take care of rendering the template in the document. This is the compiler in action. It takes in raw HTML as a string. It'll return a function which Vue calls a render function. The render function is responsible for returning an object that represents the template you passed in. We have the option of completely removing the compiler by using the runtime build. The only downside is that we're required to build the object ourselves and provide it to Vue. Let's learn how to do that. Let's go back to the editor. Back inside the document, we're going to create another div tag below the first one. We'll give it the ID of app2. We're going to create two applications and compare them side by side. The first one will use the compiler, and the second one we're about to create will not use the compiler. Switching to the script file, we'll create a variable called vm2. Its value will be the vue.createApp function. Then, we'll chain the mount method. The element we'll mount to is #app2. The data for this application will be the same as the first one. We'll have two applications with identical data. This example will help us see the difference. Now the question is, how do we create the object without the compiler and pass it on to Vue? We can do that by creating our own render function. The Vue instance allows us to create a render function by using the render property. Set this to a function. This property is optional, but if you provide it, then Vue will allow you to create the object yourself. Inside this function, we're required to return an object. We could create that object ourselves, or we can use the vue.h function. The vue.h function will help you create the object in the correct format. It'll also take care of filling in the blanks for us. Therefore, we'll return the vue.h function. H is short for hyperscript. When we think of HTML, we know that it means hypertext markup language. That's what it is. It's a document made up of text. Hyperscript is similar, except you're using JavaScript to create HTML. The development team behind Vue uses H instead of spelling the full name to reduce file size. This function has some parameters, but we're going to use the first two. The first parameter is the name of the element. Let's pass in an h1 element. The second parameter is the content inside the element. You can set this to a string, but I want to output the message inside the data property, just like the first application. During the render process, we have access to the proxy methods, and properties Vue sets up for us. Since that's the case, I can pass in this .message. It's not necessary to use an expression. Alright, let's give things a test. Refresh the page to view the results. We have two identical applications. The difference between them is that the first application is using the compiler. The second app is manually creating the object. We are skipping the step of compiling a template from a string. Let's see what happens if we remove the compiler from the build. In the resource section of this lecture, I provide a link to CDN.js. CDN.js is another CDN platform. We are on a page for different links to different builds of Vue. Search for the link that says vue.runtime.global.js. This build is the version of Vue without the compiler. Its file size will be considerably smaller. We are going to copy this link. In the document, we will replace the current CDN link for Vue with the link we copied. Go ahead and refresh the page. This time, only the second application will load. What happened to the first one? Since we're using the build without the compiler, Vue will not bother compiling the template we had earlier. This will ultimately result in a broken application. This makes it very clear as to what the differences are between the two builds. The runtime build is the preferred build to use. It does have a major downside. We have to write render functions to build our templates. It isn't very appealing. It would be so much nicer if we could continue writing the template as we always have, but continue to gain the performance benefit of the runtime build. Luckily, there is such a way. We can use the Vue CLI. I'm getting a little ahead here, but I want you to be aware that there is a way to make this process easier and still gain the performance boost. I promise we'll dive into the Vue CLI later in this course. There are still a couple more things I want to discuss. So for now, I'm going to comment out the second application inside the JavaScript file. Then I'll change the script back to the full build. Lastly, we'll cut the value inside the template property from the first application back inside the document. I find this the simplest way of doing things. If you want to use the template property or the render function, then by all means, go for it. Lastly, we'll remove the second div tag. That'll do it. In the next couple of lectures, we'll begin diving into components. Components are the most commonly used feature in Vue. They're not hard to understand or use. First, we must ask ourselves, what are components? Components are the pieces that make up your application. It's stuff like the header, footer, and content. It's basically the sections inside your HTML. Storing the template for an application in a single file can be hard to manage. Therefore, it's ideal to split the template into separate files. This is what's called components. Components are templates, but they're a bit more than that. They can contain their own data, methods, computed properties, and watchers. By themselves, they can't do much. They're meant to be used in the main application. On top of allowing you to split your code into separate files, they are reusable. That part is optional. For example, you would create a header component but only use it once since most sites only have one header. On the other hand, you can have a post component but use it multiple times because sites can have various posts. It's up to you in the end how you use components. Alright, let's see a component in action. Components must be created before we mount the application. That's important to note down. We're going to write the code before we call the mount method in the app.js file. The component we're going to create will be simple. It will render a message. We can create a component by calling the component function. This function is available after we create the Vue application. This function has two parameters. The first parameter is the name of the component. You can name your component whatever you want. There are two naming conventions Vue encourages, kebab case and Pascal case. Kebab case is when all characters are lowercase and words are separated with hyphens. Pascal case is when every word is capitalized. On top of Vue's naming convention, I'm going to recommend you namespace your component names. Namespacing is the idea where the name you give something is unique to your project. Some people will use the initials of their project or their name. Then you would follow it up with the actual name of the component. For example, if we were creating a blog application and creating a post component, we could name this blog-post. There are plugins you may end up using in your application that provides their own components. To ensure you don't face any name collision issues, it's recommended you namespace your components. In the end, it's all up to you. Since this is just an example, there's no need for namespacing. We'll keep the name simple. We're going to call this component hello. The second parameter for this function is a configuration object for the component. The settings are the same settings you would use in a regular Vue instance. This means we can add the data, computed, and methods property. The main advantage of using a component is that these properties values are unique to this component. Even if we have another component with similar named values, we don't have to worry about naming collisions between components. Not every property is available. For example, the mount method can't be used with a component. Even though components are created similarly to Vue instances, they can't be used to create an application. If you tried using the mount method, then you would receive an error. Components are meant to be used as pieces for your Vue application. One of the problems with writing a component is not writing the template in the document. This restriction forces us to use the template property. Let's create the template. We'll add the template property to the configuration for the component. The value will be a string literal. We're going to add an h1 element with the message data property. The message doesn't exist because we don't have any data in the component. Let's work on creating the data property next. We'll set the data property to a function where we'll return an object. Inside this object, we'll create the message property with a value of hello world. That's it. We've created our first component. By using the component function, we've registered a custom component. Custom components can be used in the Vue instance or in other components. Let's use it inside the Vue instance. From the Vue instance, we're going to remove the data function. The message will come from the component. We don't need to store it in the instance. I want to be clear that even if we kept the property around, the application would still work. The instance data and our components data are isolated from one another. Vue will not throw an error for having data properties with similar names. Moving along, to use a component, you create a set of tags. The name of the tag will be the name you gave the component. It's the same value you passed into the first parameter of the component function. In our case, this would be hello. We're going to create 3 copies of this component. Vue will replace this tag with the template you passed into the component. We have the option of using self-closing tags. Let's refresh the page to view the final result. The hello tags were replaced with the components template. The expression we had in the components template was interpolated. Currently, each component has the same value for the message property, but the data is unique to each component. We can prove this further. Opening the Vue Developer Tools, we will find the root component along with 3 hello components. The hello component may be called an anonymous component because we haven't registered a name for our component. We will learn how to assign a name in a future lecture. It's not something we have to worry about at the moment. The root component will not have any data because we removed it. Each hello component has the message inside its data property. We'll select the second hello component. Then we'll update the message property to something else. After updating it, the message expression inside the second hello component was updated, thus proving the data is unique to each component. Alright, that does it for components. There's so much more you can do with components, but we'll get to that later. As your application gets bigger, you'll want to split your code into various files. Components help us with that. Before we dive deeper into components, it's time that we start considering the tools necessary to scale an application. Things are starting to become difficult. It's only going to get increasingly difficult to explore other parts of Vue. We also should be using the build of Vue that doesn't come with the compiler. Using the build without the compiler means we have to code objects rather than regular HTML. How do we overcome this? The next section will cover these tools to get you up to speed. If you're as excited as I am, then I'll see you in the next section.